Good afternoon, everybody, and welcome to Parliament House. This afternoon, you're participating in the Independent Coal Seam Gas Science and Law Forum. As you probably well realised, we have actually had a much bigger response to the functions that we've arranged for this afternoon, so we've fortunately been able to bring everybody into the theatrette for both the two workshops, which we're about to commence, plus the evening forum. Who am I? My name is Hugh Price. I'm a farmer and a landowner from Corindai, and for my sins, I'm the chairman of the organising committee for this event today. Now, periodically during the day, we will hopefully be able to recognise some members of Parliament coming and going, which they've indicated they will do, as well as some ministers as well. And obviously we'll thank them for their attendance. Why did we organise this event? Particularly important, a question which has arisen several times only this morning. Last year, the New South Wales Chief Scientist, Mary O'Kane, at the request of the Premier, issued an initial report and review of the science of coal seam gas development. The ongoing nature of the review now provides an opportunity for public discussion on the existing science of coal seam gas development, especially as it relates to water, soil, air quality and health. Almost 12 months ago now, at a cabinet meeting in Tamworth last year, the then Resources Minister gave a commitment in answer to a question that if clear scientific evidence was provided from scientists and experts that the CSG industry would in any way harm or be detrimental to the land, water and agriculture or the environment, then he would not let the industry proceed. Now, as you'll all be aware, we have a new Minister for Resources and Energy, Mr. Anthony Roberts, who only yesterday, in an ABC radio interview, stated that he's a firm believer in strong science, honest communication, and when the difficult questions arise, which we know they do, water will come first. So you can understand the objective of what we're trying to do today. We want to look at strong science and honest communication. We are presenting evidence and expert commentary on the science and the law of this industry and providing an opportunity for our political representatives and the general public to identify and understand the gaps in this science and legislation and suggest solutions and strategies to these deficiencies. Now, I'll briefly, in a few moments, introduce our first chair for this afternoon. Just a few minor housekeeping things. Several people have also asked, how can you access a lot of the information that already has been amassed for today? And for those with a pen, it's fairly easy to remember. A website which is live now, www.CSG Science Forum, one word, .com. I'll repeat that, www.CSGScienceForum.com. One of the other minor little housekeeping things is, please, if you haven't already done so, would you turn your mobile phones off or at very least put them to silence? And because our numbers have exceeded our expectations, you'll always be able to get a drink and a cup of coffee and a cup of tea, but you might have to get a bit competitive if you want to get something to eat. So without more ado, we'll go into our first session this afternoon, the first workshop, which is the hydrological science of CSG. What is it to tell us? Our chair for this afternoon is an eminently known scientist in his own right. John Williams is a fellow of the Australian Academy of Technical Sciences and Engineering and holds the prestigious Farrer Memorial Award for Achievement and Excellence in Agricultural Science. He is one of Australia's most respected and trusted scientists with extensive experience in providing national and international thought leadership in natural resource management, particularly in agricultural production and its environmental impact. He was trained and is still trained, we hope, as a soil physicist and hydrologist with particular interest in the movement of water through the plant root system to recharge groundwater. John recently retired, as many of you would know, after some 6 years as Commissioner of New South Wales Natural Resources Commission. He was former Chief Scientist with New South Wales Department of Natural Resources following his retirement from CSIRO as Chief of Land and Water in 2004. John is currently the Adjunct Professor in Public Policy and Environmental Management at the Crawford School of the Australian National University and Adjunct Professor of Agriculture and Natural Resource Management, Institute Water, Land and Society at Charles Sturt University. Everybody, I give you John Williams. Thank you, John.
Thank you. I'm so pleased to be here today to act on your behalf as a chair to facilitate our very able panel we have who've worked through these problems of the hydrological sciences and CSG production, and what do we really know from that. And the mechanism I'll use, I think, to do that is first of all recognise there are a whole lot of issues with coal seam gas and land use that we can't deal with today. The whole big issue of greenhouse gas behind it, that's a big one. The issue of impact on vegetation and biodiversity, the impact of land use and farming directly are things we can't deal with this afternoon. But what we can deal with is to focus on groundwater and coal seam gas extraction. And can we maintain the integrity of our aquifers and our river systems indefinitely and extract the coal seam gas? That's the question. The issue of can we manage the system? What does the science and engineering say in managing the aquifer systems that are associated with coal seam gas and our freshwater aquifers without compromising our freshwater aquifers and our surface and groundwater systems on which we depend? So that's the frame I'd like us to keep within, if we can, so we can get to some of the substance of the science and engineering. So the way I will do this is now introduce the panel we have here, and all these folks sitting to each side of me are people I have never formally worked with, so it's not a set-up show. I don't know what they're going to say. They are going to say what they know to be the truth in terms of the science and the engineering, and drawing on their experience and their reading and their intellectual capacity. The person sitting across at the beginning of the table on my left is Peter Serov, and he is an ecologist with Australasian operation Stygoecologica, which is about the biology of groundwater. He's an aquatic groundwater ecologist who's worked on a range of environments, and this is really important stuff because this is about how the ecosystems, the groundwater dependent ecosystems, which are very diverse in the forms, the discharge of the water in the landscape and the ecology of that, and how that's affected by the way we do coal seam gas extraction and largely interfere with the gradients of pressure in our aquifers. So he specialises in the ecology and identification of stygofauna, which are groundwater organisms. So Peter is then supported, so we have the biology there, and then we come across to Gavin Mudd, who is a senior lecturer at Monash University in the Faculty of Engineering. He's come all the way from Melbourne and he's going back at 10 o'clock tonight to teach tomorrow morning, so we do appreciate that. But Gavin is a course director of environmental engineering at Monash University. He's had extensive studies in the hydrogeology with many mining issues and particularly coal seam gas projects. He's written a great deal of research papers in the technical literature. He's had extensive experience in coal seam gas and mining in both New South Wales and Queensland. And I know we're focusing on New South Wales to a large extent, but we're drawing on experience with coal seam gas wherever the science can help us understand what we know. And then on my right, Phillip Pells comes again as a civil engineer who spent 40 years professional career specialising in geotechnical and water engineering. And he was a senior lecturer in rock mechanics at my old university, Sydney University, and in 2002 he was appointed an adjunct professor at University of New South Wales. He's worked in Sydney as a consultant for the mining and civil engineering since 1980. So he's taken a keen interest in coal seam gas in New South Wales, particularly with its impact on groundwater and surface water systems. So again, we have a great deal of experience to draw on here this afternoon. And then finally, and our gender balance isn't too good, but we have some, but we're very pleased to have Andrea here, Andrea Broughton, who I know a little bit, and she's the only one I do know a little, because we worked together in some ways on the Liverpool Plains catchment hydrogeological mapping process for salinity quite a few years ago. So, but then Andrea fled to New Zealand, which is probably a good thing, and she's working there with as a principal hydrogeologist at Groundwater Solutions International, New Zealand, and she's remained active in reviewing coal mining groundwater impact assessments at the request of communities in the Namoy Valley catchment. So we have 4 people who've got a range of hydrology, engineering, ecology, and groundwater stratigraphy in front of us. Now, what I want to do is don't you folks come all this way to know what the science says, and you have questions, and I want to get to those questions. If after the questions that I ask this panel do not satisfy you, or the questions are not the questions you've got, we'll have some time for those. But first of all, I want to ask Gavin right up front. In the New South Wales Department of Planning requires a justified and tiered assessment of impacts on surface and groundwater. This includes inter alia quantification of the coal seam groundwater volumes likely to require extraction and an assessment of the impact that extraction on existing groundwater resources and users. Can you tell us the science behind such an assignment, and what are the key issues in the interaction between coal seam gas extraction and groundwater systems, and what is it that we need to get clear, and what does the science and engineering tell you?
Yeah, thanks, John. One of the first steps in any sort of impact assessment is actually having a really good baseline. So, i.e., what's there before you start? Now, that may mean measuring the water levels, making sure you look at all the water levels of the different aquifers, all the different layers of rock that contain groundwater, and also looking at the chemistry as well. So understanding the composition, whether it's the salinity, the heavy metals, the radionuclides and organics, making sure you have a good baseline. So, and also dissolved gases like methane. So that way we know what's there before we start. Then, of course, you need to look at what the nature of a project is. With coal seam gas, there's water extraction in order to allow the methane to flow. So you need to look at issues such as well integrity, how much water comes out, the quality of that water, if there's hydraulic fracturing used or not, all of those things, and then look at what the potential impacts of that may be. And depending on the scale of a project will depend on what, how much effort may be required. But some of these things, the groundwater system is often a very slow-moving system, so these things take time. It's not a simple study at all. So certainly the way I would do it would be to get really good baseline, make sure there is good transparency around the data for that, and then sort of scale the level of work required to the scale of a potential, say, coal seam gas project, whether it's a pilot project, all the way right up to a large-scale commercial project. So I think that's sort of what I would think would be a good process. And finally, a really important step that's often missed is after a project's been up and running for a while, check the predictions. How accurate were the predictions? And that's something we rarely ever do actually across impact assessment. So that way, if we predict an impact of 10, has the impact actually been 10 or has it been 1 or 50 or whatever? And so making sure that we do that step as well so that we can inform ourselves of how accurate are our predictions in that impact assessment process.
In going along that way, how far do we use the precautionary principle in those sorts of analyses?
Well, I think one of the problems we always have is because groundwater is such a slow-moving system, sometimes it can take a long time for that, for the full impacts to actually become obvious. So in that way, we often start small. As we do when we're doing pharmaceutical trials, we don't just instantly go and test the whole population with a new drug. We test a handful of people first, then 50, then 5,000, then 50,000 maybe, and then after the results from all of those different studies come to be, then we actually say, well, okay, yes, we've tested all the things, we have good data to underpin public safety, and that drug will then get approved if it meets public safety. So in that sense, that's really what we should be doing in this sort of process as well. And I think to me, the big weakness is that some of these things, the follow-up studies on impacts from projects in Queensland and even here in New South Wales as well, some of these haven't really been done. So we haven't started that sort of smaller scale to understand what's happening at the smaller scale projects to inform us of what could happen at the bigger projects.
Okay, that's important. Now, I know, Phil, one of the things when we do these assessments, one of the key things that seems to be confusing in the public is what are we doing to the aquifers and what are we doing to the water in the coal stream measure. That's absolutely fundamental, this issue of volume and pressure that's often confused.
Yeah, I think you probably all realise that what we are fundamentally doing in CSG is, in order to get the methane to flow out of the coal seam, which isn't a gas, it is not a gas in the coal, it's actually methane molecules glued to the coal. In order to get that to become a gas and to start flowing, we have to depressurise the water. It's a matter of reducing the pressure. We don't have to physically take all the water out. We have to depressurise it from what may be, say, in the Narrabri thing, it's 1,000 metres down. So we've got 1,000 metre head of water we've got to depressurise and reduce to close to zero. A head, you imagine a column of water 1,000 metres high. So take the MLC centre, put 3 of them on top of it, and you've got a column of water that's still not 1,000 metres high. That's the amount of water we've got to remove, the pressure from that water before the gas starts flowing. So when we depressurise that water at depth, we will also take out a certain quantity of water. But what gets terribly mixed up is depressurising and quantity. You can depressurise something very easily without taking very much water out. Or you can take a lot of water out without depressurising it very much. And it's really very important to get your head around the difference between these two things. They're quite independent of each other. If you're a farmer and you play around with the hydraulics in a tractor and you've got a really nice rigid tractor system, you know that you've just got to get a pinprick in that thing and go psst, and you've got no pressure. Almost nothing has been taken out, but the pressure's gone. If you had a big balloon of oil in your pressure system and you make a hole in it, it goes on pouring out while this balloon squashes. So these two, depressurisation and water quantity, are two separate things. What affects a farmer and the water that he can pump out of a bore is not how much water a CSG project has taken out, it's how much they've depressurised the system. Because if your bore previously had water coming out to within 20 metres of the surface, and they depressurise the system, it won't come out to within 20 metres of the system, it'll be 40 metres down. It doesn't depend on how much water that took out, it's just a depressurising thing. And if the water doesn't rise up your bore, you can't pump any out.
Philip, what tools of science and engineering have we got to make some predictions of what that pressure reduction will in fact do to the availability of water?
All right, the tools we have are some pretty sophisticated numerical analyses and modelling tools. They are difficult to implement because there are a lot of uncertain parameters of the ground, how much water is stored in it, how permeable it is, and so on. But the tools are there. The fundamental problem of our system at the moment is that the assessment of the potential impact using those tools is made by the person who's doing the impact. So a proponent for a coal mine who has to assess whether there's likely to be an impact on the environment is the person who pays a consultant to do that impact. Now, human beings being what human beings are, if I'm paid for by Mrs. Smith to look after her interests, I will tend to favour Mrs. Smith's desire for the outcome. And our fundamental flaw at the moment is that our assessments using these tools are not independent.
Okay, I want to switch now to me. Did you want to say something on that? I just want to switch across now to some ecology and hydrology, and I'll ask Peter and then I'll ask Andrea to comment on this issue. When describing the existing surface water and groundwater environment and dependent ecosystems, what constitutes sufficient baseline data or do we need a catchment-based approach that flags the limits to the environment's carrying capacity? What is it we need really to be able to assess the impacts on water-dependent ecosystems and the hydrology that's associated with that? Andrea will do the hydrology. I think Peter will do the ecology. Okay, let's go.
Okay. One of the issues with CSG and coal mining in general, or any activity that...
A bit closer to the mic,
Oh,
Peter.
sorry.
You've got a lovely, gentle voice.
Any activity that interferes with an aquifer, whether it's through changes in water pressure, water level, water chemistry, has the flow-on effect of impacting on the ecosystems, the environment. Now, typically, we've all heard that the environment has been... The word environment has been put out there extensively, but it's never really been defined as what is the environment we're talking about. Now, in terms of groundwater, there are a vast suite of different ecosystems, everything from terrestrial vegetation across the landscape, most of our rivers, certainly along the Great Dividing Range. We've got subterranean ecosystems that occur in most of our shallow aquifers. We have even marine and estuarine systems that all depend on groundwater. Now, in terms of these ecosystems, what isn't being done is an assessment of what biodiversity and what ecosystems are associated with the areas that are currently being impacted by, or potentially impacted by CSG. And so there's no measurement done on, first off, what ecosystems are there, what are their condition, and because a lot of these ecosystems, like groundwater, change slowly, they're adapted to conditions of relatively constant water chemistry, temperature, water levels. Different impacts have different effects on different ecosystems. Now, examples of this is, as we've just been talking about, drops in water tables. Now, many of our terrestrial vegetation communities, our big tree communities...
Can you give us some examples that you've worked with?
Yeah, certainly. Our wetlands have different levels of reliability on different levels of groundwater. So where we have shallow aquifers, which may be at or near ground level, we have wetlands developing where we have groundwater levels at 5 to 10 to 20 metres. Many of our large woody vegetation are actually drawing and relying on that groundwater and access to that groundwater, particularly during dry times. Now, in regards to water chemistry, a lot of our rivers that actually are groundwater fed, our subterranean ecosystems, which are very complex and quite vast, all rely on consistent groundwater chemistries and groundwater temperatures. In relation to pressure, our Great Artesian Basin supports some of the most unique wetlands in the form of mound springs in our western regions. Now, drops in pressure, particularly in New South Wales over the years, have meant we've actually lost many of these, and each and every one of them would have had endemic fauna, that the indicators and bioindicators of a particular water chemistry. So what I'm saying is that in the past, all our hydrogeological assessments of environmental change has been focusing on the water chemistry, the water level and water pressure. What hasn't been looked at, and certainly with baseline studies, the biological impact of that. And so this is what's missing from the current assessment process. It's starting to come in, but the length of time that we need to actually assess many of these ecosystems is not being taken into account, and therefore we're missing out on using these resources as vital indicators of the groundwater quality and its effect of the coal seam gas activities on the landscape.
Yeah. Of course, in fairness, as you said, the coal seam gas and mining is not the only thing that's been had a detrimental effect on groundwater levels in the Artesian Basin.
No, exactly.
Yeah. So, as scientists, we want to know how the system works, and we'd like to see everybody on a level playing field. Look, I want to come back to you in a minute, Peter. So talking about critical thresholds on the issues you raised, the critical thresholds for our ecosystems and how we might deal with those, because that's a critical part of the guidelines. But before I do that, the issue of knowing sufficient baseline data, Andrea, in a catchment or a landscape, you've done a lot of work to show how important it is to understand how the whole system works. Where do you think we are in the science of that back in Australia, understanding where we're putting our mining and our agriculture and our other things? What's the story with the whole landscape story? Do we need to know it?
Yes, we do, John. We need the sufficient baseline data. That is absolutely important. So in order to have this, we need data that represents the surface and groundwater environmental system that groundwater dependent ecosystems rely on. And that is looking at all of the different layers of aquifers and aquitards in the area, in the landscape. And that is done normally with monitoring bores and surface water monitoring. And the data that needs to be collected, it should be daily, monthly, seasonal. It needs to cover climatic cyclic events like floods and droughts. And like the Office of Water, they actually require 2 years' worth of baseline monitoring data so that we've got a good handle of what the system is now before we actually do any coal seam gas projects. The sort of things that we need to measure are physical and chemical. Peter's just been talking about the biological. The physical, we need to know the initial water levels. We need to know the temperatures and the acidity, the pH, what the salinity is like before the project actually starts. These are all background information of what, it's a snapshot of what is it like in that system before they alter it. So we're looking at total suspended solids, we're looking at the chemistry, we're looking at heavy metals, looking at radioactive like uranium, and other toxic elements that could be found in the CSG produced waters. We need to know what the baseline, what is actually out there now, because some of these things are actually naturally occurring in our environment, but just in much smaller quantities.
Okay, so I now want to throw back to, while we're still talking about the natural ecosystems and their impacts. Peter, what's the story with how does one determine the critical thresholds for negligible impact of CSG or any other impact to surface water and groundwater sources for dependent ecosystems? How do we know what's the critical threshold? How do we know they're? How do we monitor them?
Well, the difficulty with monitoring, the difficulty with coming up with a critical threshold is you have to basically impact the system before until it falls over.
Well, what about modelling to help predict what that might be, predict the impact?
The first step for certainly biological assessments is understanding what the natural variations and fluctuations are in both water levels and water chemistry, and matching that with our knowledge of the biodiversity associated with that. Now, each type of ecosystem that I mentioned before, everything from vegetation to stygofauna, have different rates of reaction to different impactors.
So it's not just enough to say the water table dropped by 50 centimetres, so that's okay, when you don't deal with how long and for when and what's in it.
That's exactly right. And it's identifying what ecosystems are there. So if we have a shallow aquifer which supports groundwater fed wetlands, and those wetlands are 50 centimetres deep, and we know that the impact, modelled impact or actual impact, is going to drop that water table by a metre, we automatically know that that ecosystem will either struggle or cease to exist. It's by understanding the parameters that dictate the sustainability of each of the ecosystems associated with that aquifer, then we can then determine what the thresholds are. But this, again, requires long-term monitoring of those ecosystems to find out.
The bottom line is, though, Peter, can we establish the critical thresholds? As an ecologist, do you think you as an expert, are able to establish what are critical thresholds? Can you do it?
We can.
Okay.
As I said, if we understand what changes are going to happen from modelling, we can then look at the parameters for each of the identified ecosystems associated with that aquifer, and we can then suggest what impact is going to happen on each type of GDE.
Thank you. Gavin, what you used to have a comment here, I think.
Yeah, I think one of the other things to remember is that each system is going to be different. I think, as Peter's saying,
absolutely.
in that sense. Now, if you're looking at different groundwater-dependent ecosystems, the geology is different. I think, as sort of Phillip was alluding to before. And so some of these things are very different in Queensland compared to New South Wales, and that may increase or decrease the risks depending on what things are. So any sort of concept of critical threshold or some sort of magic number, I think, is something we need to be very careful about, because it may be good in some circumstances and really bad in others. So I think that's a very important point. We need to understand the variability of the system.
Let me untangle that a bit. So you're not against, you quite see that scientifically you can establish critical thresholds, but they're not universally.
Yeah.
They're dependent on what the system is.
That's correct.
It varies across the landscape.
Okay, that's really important. Now, I want to move now back, because I'm conscious of time and I want to make sure we cover the territory. I want each panellist, if they would, comment on this sort of approach forward, because it's critical to this whole exercise of evaluation of coal seam gas and impacts on groundwater systems. To assess potential impacts on the quality and quantity of existing surface water and groundwater impacts, the New South Wales Department of Planning requires detailed modelling. Now, I'd like each of you to tell us all what represents satisfactory detailed modelling. I wonder if you might like to start, Phillip.
Okay, just before I go into that, if I can be a dissenting voice in a little bit in terms
Please
of
do.
something
We
that's
don't
gone
want.
ahead.
Yeah, please.
Baseline information is good, and the more you have, the better. But we're never going to have all we want. And I guess the difference between a scientist and an engineer is a scientist has to know everything before they do anything, and an engineer does everything before he knows anything.
I'm a scientist, he's an engineer.
That's right. We're not going to have the baseline information would have covering all the bugs, the bees, the pressures, the water, the farmers, and everything else in every area beforehand in order to make decisions. We're going to have to do the best we can. And then in terms of the modelling that we can do, we have analytical tools that enable us to make an assessment of our impacts. But I think it's very important for us to prioritise what we are really concerned about. I mean, I don't want to diminish the importance on some little tiny bug that lives in a little pile of mud somewhere or other, but the people are in this room not because of that. People are in here because of what they might lose in terms of their groundwater and water sources for farming and for production. And I think that that's what we're going to focus on. I don't want to diminish the importance of ecology, but our big ticket item at the moment is we haven't got enough water for doing what we want to do, and we're about to stuff it up, potentially to a significant extent. And as Gavin said correctly at the outset, is our normal way of working previously has been to nibble at these things. We have a small mine that expands slowly. What we've done with CSG is we've opened up 30% of New South Wales to this in one hit. We're going from exploration of doing 3 wells to 850 wells at Narrabri in one hit. And it's not a reasonable thing at the moment, and the real problem is that we're not doing the independent assessment of our impacts, and also we're not prioritising our impacts.
And are we doing the cumulative impacts in our detail modelling?
And we're not doing the cumulative either, although not entirely. In some cases we are, and there's nothing wrong with the regulations. They require this. We're actually not doing it. And then on top of that, just to be really depressing, if we do it and we do monitor, as Gavin says, and something is not as per it was supposed to happen, tough. There's no penalties, there's no police, there's no nothing.
Audit.
There's no punishment.
So what
know?
you feel we have the capacity to do the detailed modelling? Do we lack the data, or have we got enough data? You say never will have enough, but
We'll never
have we got enough to be confident?
We have enough to focus on the big ticket item. We don't have enough to focus on a lot of the detail that may be important for certain things. I accept that. We don't have the baseline data for the particular little bugs that live in a particular little dam somewhere or other, and I don't want to diminish that, but we don't have it. But we do have enough for the big ticket.
Do you think we can give people confidence that their groundwater systems for urban and agricultural use can be evaluated in terms of impact
Yes, we can,
with confidence?
but only if that work is done and financed independently.
Okay. Right, well, you might like to come back in that, Phil, but I don't know. Gavin, do you want to go next? And then maybe Andrea? I don't want to... Are you happy with that?
I'm all
Jump
right.
in, don't let me pull you around.
I'll jump in, don't worry.
Good, right. Gavin, on this issue of what represents satisfactory detail modelling.
Well, I agree largely with Philip. I guess in one sense, I think if we don't have enough data, then we really shouldn't be making decisions until we're more confident in some ways. But we know what to do. We can drill some groundwater bores. We can monitor water levels. And I think, as Andrea was highlighting, in some parts of the world, you're actually required to do things for 2 years like that to get the data that underpins the processes, so that way you can feed it back into a model and actually do some sort of 50-year projections as opposed to just sort of 1 year of monitoring. So I think we largely know enough of what we need to do. We're just not doing it, and regulators are not requiring it to be done, even though the legislation is there and it says, yes, you are supposed to do a cumulative impact assessment. And cumulative impact assessment is everything that's going on in that system. Now, in some areas that includes farming, in some areas that includes recharge zones, so we need to be mindful of things like drought or wet climates, periods, things like that. So I think we do know more than enough of what we need to do, but it's just not being done. If you look at Camden, for example, after many years, there's still, as I understand it, no groundwater monitoring being done out of Camden. So now that, to me, is a real problem. It's not to say that there is impact at Camden. We don't know. There's no data. There's no bores. So how do we know? If we get some good bores in there, we can actually have good data to underpin what the real impact is, rather than just assertion or assumption.
And that data should be available
Absolutely.
in the
Publicly.
public arena.
Yep.
Okay, well, okay, Andrea, you will go.
You're following on from that. If you've got good monitoring boards out there, then you're going to have more data to put into your model, which one of my big my pet hates is the low level of groundwater model that is required at the very beginning of the whole process of getting a licence to produce. Can I use Santos as an example?
Well, just say somebody.
It's
Yeah.
a very
Somebody.
good example.
Well, it's the only one I'm really familiar because that's what I've been working.
It's on the website. Their model's there. Yeah.
Okay, cool. Right, at the referral stage, as you know, they have put in their referral in last year. And at that stage, the mining company is only required to undertake a desktop sort of level 1 type model, however, for groundwater modelling. But you think about all the decisions that have been made at this point in time. It's so early in the piece on a very low-key model. What I see it as a low-key model.
So you don't feel the detail modelling has been done?
It should be around the other way.
Yeah.
There needs to be a lot more data put in to make a more a stronger model that actually is telling us something. A level 1 model is not actually based on very little data. It's very little data, and so they make these predictions right at the outset that there's hardly going to be less than half a metre drawdown in the Bahina alluvial aquifer, the highest up one above the Pilliga sandstone. But how can you say that for sure? I mean, thinking about where they're pumping from 1,000 metres down here, that's quite possible. But how do you really know that when you're only basing it on data that has been measured sporadically and only in about, less than half a dozen bores? Most of the bores there, which are only about 12, are in the Pilliga. The monitoring's not there, the data's not there. It is a model that's based on very little data, yet such big decisions are being made at such an early time on it. So satisfactory detailed modelling needs to be carried out. I mean, groundwater modelling is a tool. It's to determine the likelihood of risk of negative impacts to the groundwater system and the groundwater dependent ecosystem.
Do we have enough knowledge of the stratigraphy, the imperfections in the stratigraphy, the faults, the folds, all those sorts of things at a sufficient scale to do the detailed modelling? Now, Philip said when you actually prick something and reduce the pressure, it's not mind-blowing science to know that water's going to follow along gradients. So should we not assume up front that we are going to disrupt the water flow regime? What do you think?
Yes, absolutely. But even more importantly, if that's the case, then why are we not... these companies should be actually doing a proper hydrogeological investigation right at the outset, that way to determine the characteristics of the aquifers and the protecting layers in between.
But if you take Philip's point, surely the thing is to know something of the way the landscape functions earlier
Yeah,
before we get this far.
that's what I'm saying.
And
That's what we need.
are you concerned, folks, about the amount of hydrological and hydrogeological knowledge we have of our landscapes that we used to be able to have as public knowledge before we get into the use of this landscape, not only for mining but for all the other uses we can make?
I mean, I can only answer that question by example, and that
Please.
is having done a groundwater modelling for both the Gloucester and over the last weekend for the Narrabri thing. If we are focusing on the big impacts, namely the drawdown of water tables in the Pilliga sandstone and so on, and we're looking at not whether we're dropping it by 1 millimetre or 15 millimetres, but whether we're dropping it by half a metre or 50 metres, we have enough information to know it now.
Good.
Andrea correctly pointed out that, and you can't blame Santos for this, but the system has allowed the nominal approval of 850 well bore field on a hydrogeological model that would be failed in university first year or third year, and it would just be a failure. It's abysmally poor. It's not just slightly poor, it's a shocker. And if you want to go and look at the data that was used in the model, you cannot find it. And I'm not telling something that I haven't written to Santos on last Thursday, last Friday, and again over the weekend, saying, I can't find the parameters for your model. Could you give them to me? They're just not there.
They won't give it.
Andrea knows they're not there. So what I did then was I said, well, look, I've run my own model over the weekend. These are the parameters I've used. Tell me if I'm wrong. Now, they may come back to me, and to be fair, and they may come back to me. But one of the things that Andrea pointed out is the model that they ran, and I don't want to point fingers at that, but the model that was allowed to be used for this 850 well approval indicated no drawdown in the Pilliga sandstone and the aquifer above it. A very simple analysis run over the weekend, well, it took a lot of the weekend to run it, indicates exactly the opposite. Mm-hmm. And there is no way I can manipulate the parameters to get their answer. No way. So something is wrong somewhere.
So from this we can say that we asked to be doing detailed modelling. We feel that that's the principle, but we're not seeing it put into place, yet we believe from across the panel that you have sufficient technical and scientific skills to get the big questions answered.
No doubt about it. Sorry, in my humble, not so humble opinion, I say no doubt about
No, I
it.
agree.
Yeah.
Yep.
Yeah.
Okay.
I think the critical thing is modelling with good field data.
Yeah.
You have to have both.
Yeah.
You can't just have modelling without field data. You have to have both.
And I think the other thing, Gavin, is you've got to say, look, we don't know all the parameters, so let's look at a range.
Yep.
And what's the
Your
likelihood?
sensitivity
How does that
analysis.
influence the answer? There's no single answer to these groundwater models.
It's probably more powerful then to do a sensitivity
Of course you
analysis
do.
and say,
You
if
know.
they are like this, we can expect that.
Yeah. It's not going to be any worse than this, it's not going to be better than that. Then
you're right.
look at that range and say, well, is it still okay or is it a dog? If it's a dog at the low range and the dog at the high range, it's a dog.
Yeah, he's into dog breeding. No, that's right.
Very good.
Yeah,
I'd
like to have Peter come in because even though he's an ecologist, you still use these models to evaluate what the impacts are to ecology.
Well, exactly. I mean, the models tell us so much about potentially what's going to happen, and the model is only as good as the data available. Now, we've got New South Wales Office of Water have something like 2,500 monitor bores across New South Wales, but when you actually look at them at the distribution, often they're very, very localised, and most of New South Wales doesn't have any monitoring bores at all. And therefore, what do we base the models on? If we don't have the data, the models can only tell us so much. And this is where the biological aspect is so important, because we've been using biological indices in rivers for over 40 years to determine what the impact of various activities are, from drawdowns to contamination, using the life histories, the type of organisms we find within our rivers and wetlands to determine what impact has happened. And there's enough science out there to know what are the sensitive groups, what are the robust groups that can take a hammering or a nuclear bomb. And the same applies to our groundwater dependent ecosystems. We don't have exactly that level of detail, but we do know that because particularly our subterranean ecosystems, our stygofauna communities, their characteristics are they're very long-lived. They are adapted to the climate intrinsically, the climate of the water chemistry, the environment intrinsically. That environment doesn't change dramatically. And so if we find stygofauna, or particularly a rich stygofauna community, we know that groundwater has not changed dramatically over time. Therefore, it gives us a time period of non-impact in that area. These
how stable the
ecosystems.
system's been over time.
Exactly.
Yeah,
These ecosystems are our canaries in the mines.
Yeah. Okay, look, I want to come to a pretty important, it's sort of getting to that sort of stage where we know the Chief Scientist, Mary Kane, is trying to assemble her next report. And one of her briefs is to identify and assess any gaps in the identification and management of risks arising from coal seam gas exploration, assessment and production, particularly where they relate to human health, the environment and water catchments. I'd like each of you, if you would, and maybe starting with Andrea, if you're comfortable to start, to see how you go. What does the panel see are the main gaps of scientific and engineering knowledge to allow us to really be confident that we can actually extract coal seam gases and retain the integrity of our landscapes?
Well, I think obviously the one that we keep saying, and that's data, massive gap in data. In all sorts of forms. There's probably a lot of data out there, but it's actually an industry that won't actually let anybody else see it. I know in her report she's really pushing, and rightfully so, for a data repository where it's kept in one place and it's transparent and everybody gets to see it and can add to it. That's what we desperately need. But there's still going to be those situations. This is petroleum industry. That some of the data surely at some point is going to be sensitive and we won't be able to see it. But hopefully most of it will be usable. But as far as Mary O'Kane's report, on the whole, I thought it was actually quite a good report. But there were definitely some gaps, and I just want to go over a few of those, if
Please.
that's okay, John.
Mm.
So some of the gaps that there were about 6 actions under the terms of reference. And the remaining terms that really need to be addressed, and things like looking at the industry compliance. That's a bit of a hottie, I'm afraid. I'd like that seen done very soon. What is the drilling industry doing out there? Are they really complying? Is anybody really there doing spot checks just to see what these guys are up to? I know they've actually got to follow a very well written coal seam gas well integrity guidelines. They all have to follow it. It's all there in black and white. But what's actually really happening out there? Because once a bore's under the ground, who can actually see it, apart from somebody who goes down with the geophysical logging equipment to check out if it's been grouted properly and over, and protecting the aquifers that it's supposedly meant to be doing. We want to have evidence of that. We want to see the records of that being carried out, and they should be in the drillers' logs. The other gaps I see are assessing and managing risk dynamically for a coal seam gas system as they relate to human health, the environment and water catchments. She's she's tagged this, she knows it's going to be done, and this is what she's meant to be saying in her next report, so I'll eagerly wait that one. The other is looking at best practice in relation to the management of coal seam gas in proximity to residential properties and urban areas, and consider appropriate ways to manage the interface between the residents and the CSG activity. And this is going to be an ongoing study that she's doing. Inspect and monitor current drilling activities to get out there and have a look, including water extraction, hydraulic fracturing and aquifer protection techniques. These have been discussed, but they haven't actually really been looked at in detail. They haven't actually been inspected.
Okay.
Do you want me to
No, well,
keep going?
You just, if you can, quickly, so
Right,
we
quickly.
can give everyone an opportunity to speak.
Right, so the gaps in knowledge from a hydrogeologist's perspective. I find the report clear, identifies and assesses the main gaps in knowledge in the hydrogeological assessments, the lack of understanding of the whole groundwater system in the sedimentary basin. We know that the Great Artesian Basin is a very complex system and it's not completely understood yet. The lack of meaningful baseline data, the lack of high quality monitoring data, and how you manage that. the need for contractors to be very well skilled. But one of the big gaps I found in this report was that it did not adequately address the management of that risk and what that meant. She talked about all the gaps, but didn't really talk about the risk arising from the lack of quality of these data sets. And to me, that's a bit of, shouldn't that be part of the precautionary principle? I mean, this is a risk. We don't have the data, so what are they going to do about it? How are they going to address it? I think that needs to be.
Okay. Right, Phil.
I mean,
What are some of the gaps?
I think philosophically the big gap in our knowledge is time. As Gavin said correctly, when you depressurise at depth, it's going to have an impact. That's a physical reality. The biggest difficulty is knowing how long it's going to take. In some geological environments, it'll take an awful long way to work its way from a depth of 1 kilometre through to the surface. Such a long time that by the time they've finished, done and over and dusted, it'll have no impact on the people on the surface. In another environment, it could go through in a matter of a month or 2 months or 2 years. And that also depends on the geological structure, which we know so little about in some environments and a lot in others. So the time question is something that is a very difficult one. Is it going to take 100 years or 10 years? And also, how could unknown geological structures really upset our very carefully and thoroughly believed engineering analysis? And in certain environments like Gloucester, where the structural geology is very poorly known, anything could happen. And I will go to an example later on. But to me, those are the big gaps, is geological knowledge and also the time effect.
Okay.
I agree with all of that, actually. I think compliance is a really big issue. And I know when there has been rare examples of compliance assessment done in other parts of the mining industry, drillers have often been found wanting. So compliance, the time factors. One of the other big gaps I see is failing to assess things like dissolved gases in groundwater. If we're mining methane, then one of the things we should be looking for is methane in groundwater. Now, sometimes you can find methane in anaerobic parts of wetlands or estuaries, so you can find methane quite naturally in groundwater systems or in surface water systems, but typically you don't. It's a very reactive gas. So most of the time, unless you're dealing with very particular circumstances, you shouldn't see it. So making sure we have a good understanding of these sorts of things before you start, so that way we're not having this sort of fight over, was it farmers who caused this, was it drought, was it there before or not, like the debate we're having in Queensland. If we have data before these projects start up, good baseline data on aspects like dissolved gases, including things like radon as well, I should actually add, but then actually we can have a much better debate, we can be much better informed. So I think that's one of the other key gaps out there as well as some, I think, things we've already talked about.
Okay, Peter.
Well, I agree with everything that's been said so far, but for me the biggest missing gap in the initial report was any inclusion of the biological aspects and the biological linkages between groundwater quality, groundwater level, and the impact of CSG. It just hasn't been covered at all. One of the other factors that hasn't been considered is potentially hygiene of constructing a well. One issue that's come up recently in the Pilliga is the introduction of bacteria such as sulfur-reducing bacteria, iron-reducing bacteria that generally doesn't occur in groundwater. It occurs on the surface, in the surface soils. The introduction of oxygen into relatively or very low DO water conditions. It's that not covering these conditions appropriately, or not even addressing them at all, is the major gap that I see within the system, within this report.
Good. Two more things I'll address to the panel, and then we'll be going to questions. So get your questions ready. Just raise your hand, and I won't know all your name or many of your names at all. But there will be 2 roving mics to pick that up in a moment. But the really contentious issue that receives so much public concern, of course, is hydraulic fracking. I'd like to just run along the panel and those who've got experience, and I think you all have. I can't be sure, Andrea, maybe it'd place you in positions you don't need to comment. But if you have had experience and understanding of how well we know the science and engineering of hydraulic fracking, let's restrict it to coal measures. Okay? I'm wondering if, I'm asking you again, Phil, would you like to kick off? Because I know you've had some, you've got some knowledge of that.
Okay, first of all, a lot of CSG extraction doesn't require hydraulic fracturing. So, for example, the Narrabri project will not be hydraulic fractured. And that's not because of the goodness of the heart of the operator there, it's because it's not necessary, because the coal is pre-fractured. And they did try doing it and it didn't work, because the coal is so fractured that they just wasted all the liquid down these open fractures in the coal. So it's not an issue there. At Gloucester, it's a big issue because their holes are all vertical and they're doing multiple seams, and the whole project's not viable unless they hydrofracture every seam that they want to extract from. At Camden, they're not hydraulic fracturing anymore because they're using directional drilling. So you can't, we've got to break this nexus between CSG extraction and hydraulic fracturing. They're not synonyms. What I personally think about hydraulic fracturing is, in my list of concerns, it's not near the top. My big one is the water and the extraction of water and the impact on the water system. My knowledge of hydraulic fracturing as it is currently practiced, in the few places it is practiced, which is Gloucester, they don't like me for saying it up in Gloucester, but I actually don't lose up much sleep about it.
Okay, right, next.
Yeah, people are often surprised when I actually agree with Philip on that. I think, to me, it's the impact on the total system that's the real issue. If you look in Queensland, 80 to 90% of the coal seam gas bores being planned won't be fracked. So in that sense, 80, 90% of the impacts that we're talking about are completely unrelated to hydraulic fracturing. Now, it can cause issues, it can go wrong. The chemicals that can be injected, such as biocides and other things, can cause issues. Some of the other chemicals that are used are, sure, they might be household chemicals, but you don't start pouring it into your drinking water for coffee or for water, like this sort of thing. So a lot of these sorts of risks are context specific. You need to look at the aquifers and the systems, the users and so on, and make sure all of those risks are properly well assessed. And also, not just what goes in, but also what comes out. Now, the nature of hydraulic fracking or hydraulic fracturing, whether it's for shale gas, whether it's for coal seam gas or whatever, will extract out some of the chemistry from whatever formation. If it's coal seams, you're likely to see some organics. If it's shales, there are some shales that also have slightly elevated levels of radioactivity, heavy metals and so on as well, whether that be arsenic or others. So sometimes it's not so much just what you put in, it's also what you pull out as well that's really important. So to me, in that sense, there are issues with hydraulic fracturing, sure, but I agree with Philip. It's actually not the top order issue in my mind. The top order issue is the pressure changes in the system and looking at the total response of the whole system. But the other issue that is associated, which I think we haven't touched on at all yet, of course, is well integrity. But I think I just opened up Pandora's box.
Peter, do you want to make a comment on fracking?
Oh, only briefly, in that again, it's not so much the fracking that's the issue. Generally, in terms of biodiversity, coal seams, we know, don't have large fauna. They don't have stygofauna. The water chemistry associated with coal seams is usually too salty. But it comes back to wherever there's life, wherever there's water, there's life. There are bacterial communities that live in these locations. But the fracking process is so deep that, generally speaking, when it is required, it has little impact on the surface. Now, having said that, one potential impact that fracking or maybe even well installation has is the potential for seismic activity, which we generally can't feel on the surface, but it can have impacts in the subsurface by changing connectivities within sensitive aquifers, creating connectivities between aquifers that haven't been connected before, and therefore creating a contamination by mixing separate groundwaters together, and the impact of this mixing and the potential for the contamination of the water that comes out of the system is far more important when we're talking about ecosystems than actually the fracking itself. The release of various chemicals that have already been mentioned into systems that have never encountered them before can potentially have dire consequences to essentially wipe out entire communities or make that water unusable for either domestic, industrial or ecosystem purposes.
Okay. Well, look, the last question is the one that you've started to mention there, Gavin. Sorry, I'm a bit slow. Gavin, but it's the last thing I want to comment on is well construction, the casing, well integrity, and the integrity that needs to be there indefinitely, so we don't have the stratigraphy compromised. I guess again, Phil, I might start with you because I know you know something about this, but I'm sure others, Gavin does too, and Andrea may. The issue of how are we managing the well integrity that has to be there indefinitely?
I actually can't answer that question because I don't know in totality how we're managing all of the wells, and I suspect the truth is that many of them and most of them are being done as well as we can, but given the depth we're drilling at and what we're trying to do, I would expect that every single well would have flaws in it, and that's not because people are being casual about it, just because it is extremely difficult to know what you're doing a kilometre away from where you're doing it in a hole that's this diameter. In terms of interconnection and the impacts of these wells, I'd like to just do briefly, and I've got details here, you can take it after, but there's an example which I think encapsulates the issues here, and it's, first of all, it's an example of what is hidden. In 2004, the then operators at Gloucester, which was Malopa and Lucas, drilled a hole which was called LMG03. It's now been renamed Stratford 3, so you can't connect the stories anymore. LM303 is the most highly productive gas well drilled in Gloucester to date. It went down to 531 metres, and they hydrofracked 3 seams starting at 400 metres below the surface. After hydrofracking, they then decided to put that well onto test production, which means they started pumping the water out that well to start the depressurisation. And remember, the seam that they were trying to get the gas out is 400 metres down. They'd lowered the water to 80 metres below the surface, which is nothing. By that stage, they were delighted. They were getting the best part of 250,000 cubic feet of gas per day out of that hole. It was an absolute ripper. As the water level got to 80 metres, much to everybody's surprise, and up to 300 metres away, so we're talking about the other side of the road, the other side of the building on the other side of the road, bores that nobody knew about that were drilled for old mining blew their guts out. So gushes of oil and, not oil, sorry, they would have been happy with oil. Gushes of water, mud and slush came shooting out of these holes up to 300 metres away. Okay. Panic, the Australian Stock Exchange was informed and they stopped the pumping. The conclusions that were drawn from that were, and I can quote it, and it's written down here, is that this demonstrates how good the interconnection is across the system there between all the coal seams at the different levels, how good the connectivity is across our stratigraphy. 18 months ago, the now proponents published the results of their groundwater assessment of Gloucester and said that the conclusion of this investigation was there was no connectivity across the system. Yeah. No mention is made of the record of Stratford 3. It doesn't appear anywhere in the documentation. You will only find it if you go searching under Malopa and Lucas. I thought that was all to it, the story. I then discovered over the weekend that happened in September 2004. In October 2004, they had plugged up these various holes that had blown their guts out and started pumping again. Okay. The pump then broke down. So they held it for a while and started pumping again in December. In December, the integrity of the well casing was so bad that the gas was coming up the outside of that well, not the inside of that well anymore. So, to me, an honest appraisal of our system and our risks is not to say all wells are like Stratford 3, nor is it to say that all wells are perfect. The reality is that the risk assessment must not hide these cases, nor must we overreact to these individual cases. We have to learn from them. And I don't know how many other things like this are buried because they're not good karma. Rather, people not know about them. I guess my real concern is we haven't got an honest system going here, guys. We don't know what the hell's going on.
Thank you. How are we going? Gavin?
Yeah, well, integrity, I think, is the big issue in a lot of ways. Certainly the evidence coming out of America is that the sort of famous Gasland scenario where someone can actually turn their water tap into a nice flame or stove even, but the reason why that's happening, I think, is because of actually well integrity. You're getting, as Phillip sort of suggested, you can see examples where gas comes up the outside. Now, sometimes that's because drillers are working too fast, because if they can drill it faster, they can get onto the next bore and they get paid by the metre. So the faster they drill, the more money they get. So I think there's incentives there that I think mean that actually it's not always in the best interest of a driller to stop, make sure they seal off an aquifer properly in the way that the drilling guidelines and the codes and so on all suggest that should be happening. So when you're looking at some of the various examples that are being put out there, sure, some of them are extreme ends, and sure, there's many examples of bores that actually do have high integrity, and there's a lot of test work that can happen, whether it's downhole probing, gamma logs and other methods that can actually test the integrity of a well. But primarily, where's the independent audit? I think it sort of was mentioned earlier. So that's the sort of thing we really should be focusing on, make sure we actually have good evidence behind this. So if someone says they're going to do something, they've actually done it, and it can be validated in that sense. So, yeah.
Okay. Well, the issue then of well integrity, Andrea, have you got a experience there?
I'm just, again, because most of my work is to do with Narrabri. My big concern with well integrity is that we rely, the coal seam gas industry, relying on the coal seam gas well integrity guidelines. The government is, they've got fantastic guidelines, and as long as they think that the mining company is actually adhering to that, then all our bores will be safe, this bores will be safe. But my concern is some of the wording that I came across within the guidelines, and that they talk about protecting producing aquifers. What about those ones that are aquifers still, but they're not produced as such? They're not being used for drinking water. It doesn't make them any less of an aquifer. So my concern for Narrabri gas field is the shallow groundwater system. Again, talking about the Bahina aquifer, which overlies the Pelaga. It's used for livestock, not for drinking water, but it's still a producing aquifer in my mind. But as far as the guidelines are concerned and Santos is concerned, they are looking at protecting the Pelaga sandstone aquifer, and from what I understand, they're not actually separating the two aquifers out. To me, that's the well integrity discussion. That's where I'm concerned. I'd like to see the two of them actually screened off from each other because they've got different water quality. That's probably most of my concern.
Okay, well, we've had a good go at trying to get the issues out and talking about them, but I want to hear where the big issues are scientifically and engineering-wise that you have and can ask the panel. Now, if we've got a mic, where's one? There's a mic over there and a mic over there. So put up your hand. We'll take this man over there and then this man here. It's in the row just up there. Just stand up might be the best way, then we can be sure.
Cheers. G'day.
Say who you are and please have the question. Yeah.
G'day. My name's Paul Reynolds. I'm from Camden Council and I work in the environmental health team.
Mm-hmm.
The comment was right about the lack of baseline monitoring for the Camden gas project. It's only been recently that they've installed some monitoring wells in the area that was proposed for the northern expansion, and from that they're then going to try and infer what impacts might have occurred. So when I started at Camden, which was only about 3 years ago, I was surprised, to say the least, that they hadn't done any baseline monitoring. It had only been a level 1 desktop study that was used to justify proceeding with the gas project. But question for you, and I'm hoping I've got names right, but Phillip, you did a study over on Thirlmere Lakes. Was that you? Yes. I was just wondering if there are any lessons that you learnt from the impacts of coal mining on the lake levels that perhaps might be useful in understanding what the impacts for the Camden area with the coal seam gas there.
Okay, Phil.
Well, the lessons I learned from it's extremely difficult to prove an impact that is relatively small, particularly in a highly variable climate like ours. If we're extracting water out of the groundwater system, you won't notice its impact on our average rainfall events or when rivers are flowing heavily. You'll only notice it in the drought periods. And in the drought periods, there's a difficulty of discriminating what's due to the drought and what's due to the mining impact. So it is actually, an experience I got from Thilmia, very, very difficult to nail down a definitive answer, even in a situation like that. We concluded that there was likely to be an impact from the mining on the lakes, but others concluded that we can't be sure about it. And it's the difficulty of, the old mathematical difficulty of answering small differences. The difference of a small difference. It's very difficult to do.
Okay. We had a question over here. Can you just stand, and there's a man here with a mic. Then the gentleman next to you. Yeah. And then maybe right.
Can you hear me? Yes. I'm an agricultural scientist and I'm a Wagyu farmer.
Yep.
I liken the discussion to the panel. I actually want to talk about well integrity in a moment, but first, the discussion of the panel is like a firing squad discussing what is the most effective calibre for the weapons they're going to use. Okay. When the burning question is, who are you going to shoot? Yeah. You're going to shoot me. As a Wagyu farmer, I cannot possibly conduct my business where all my creatures have to be DNA profiled before they can reach the Japanese market. I can't conduct my business if I have people driving on with trucks, opening and closing gates, bulls getting out, all that thing. It's impossible. So the impact of the industry, of the CSG industry, on the surface activity is really the prime issue, and it's all going to happen on farms, so the entire impact is going to be on farmers. But putting that aside, because I'm not allowed to discuss any of that.
No, well, that's a pity, but you're dead right, and I acknowledge that.
Okay, thank you. Well integrity. Years ago, I was on the Merriwar Council. We sunk municipal bores into the Pilliga aquifer. They were 700 feet deep. The pump was 14 feet long. When we tried to pull up one of the pumps for servicing, the bore had bent and the pump got stuck halfway up, and the bore was only about 9 years old. So the well integrity over time, I think you can safely say 100 years, well integrity is non-existent. Strata shift, pipes bend, pipes break, strata intermingle. Well integrity is a furphy. Well integrity doesn't exist over any meaningful geological timescale. Thanks.
Just make a quick comment on that. I'd heartily support that in many ways. If we think of our experience in the Great Artesian Basin, what we thought were pretty good bore standards 30 years ago, we now realise are still not good enough. Now, coming back and putting cement plugs in bores, we may find in 25 years may not be good enough. So in some ways, I think our standards are always evolving, and we like to think they're always getting better. So it's a really important issue, and it's something that I think I was out in South Australia, well, last year and again a few weeks ago, and one of the bores there was a groundwater pumping bore, and like sort of Phillip was just talking about in terms of Stratford 3, this bore it was a groundwater pumping bore put in 30 years ago with good standards apparently. 4 monitoring bores around it in a standard square pattern. Those 4 monitoring bores are in perfect condition 30 years later. The pumping bore has actually caved. Now, when I say caved, you've basically got an open cave opening up around the bore. And so what we don't know is, did the bore cause that solution feature? It's in limestone geology, so we don't know whether that's caused that or whether it just happened to hit a solution channel, like an open fracture basically inside that limestone, and it's now expanding. Then again, it's an end member. It's one of the extreme examples, but that's the sort of thing I've never seen in my life before. So you can get such, and this is, the monitoring bores are literally only 1 metre either side of this, well, probably 2 metres actually. So in that sense, you can get this extreme variability in the system. And so well integrity is a huge issue, and I think that's why we need better compliance, we need better transparency, and certainly much better independence.
Can I
Okay.
just one
Yeah,
very
please,
quick
Phil.
comment, just to put this in context.
The minute.
You must realise that these wells only have to last 10 or 12 years, so it's actually a little bit unfair to compare a long-term groundwater well that may be 30, 40 years for a CSG well, which will not only have to operate, will not operate more than about 10 or 12 years.
But Phil, the well will still be there.
But then it's completely plugged.
But is that plug sufficient? That's the
But
question.
the other point about it is that after that period, the groundwater system is then allowed to start recovering. So you've just got to be a little careful about using an extreme in one example for another. It's not quite valid.
Okay.
10 minutes, John.
Right. We have one here, a gentleman in white shirt, just reaching for the mic now.
Hello, great talk. Robert Banks from Gunnedah. I'm a soil scientist and geomorphologist with a background in government, and I work for myself now. I've got a very simple question, which probably expresses my level of understanding of some of this, but if you do have drawdown in bores from the depressurisation of an aquifer, does that result automatically in a decrease in yield?
Absolutely.
Right.
To the point where you'll get nothing.
Right. So it's not just a case if you drop the water level by 40 metres, you can't go deeper into it because there's still standing water there and still expect the same yield.
No, your yield is going to drop like a stone. I mean,
Thank you.
Just use an example, the little farmers down at Thirlmere and so on, at Sown, they rely on half to 1 litre a second bores.
Yep.
Probably 15 of them have nothing now because the water levels just dropped to the bottom of their bore. They've got nothing left.
And I guess I'm asking for a comment here. There's a bit of who can the community trust to do good science and then review it and then either say this is worth trying or not worth trying, and there's a monitoring aspect there, because once you start doing things it seems that companies just monitor things and report it to the EPA and disappears into a black hole. Do you think expert bodies such as your own, as in you people there today, have any influence over that process ultimately?
Gavin?
I'll go first. I think Andrea made a really good point before, is there's this thing called the internet, there's this thing called the digital age where data can be made very easily available, it can be mapped, it can be sent from a sensor in the bore right to the internet within seconds. So the ability to actually make data available to anyone, not just some people who are interested in it, but to anyone, is actually better than ever in history. So in that sense, you're starting to see that in some parts of the CSG industry, so I'll give Santos credit in one sense. They've at least got their water data online, and we can debate about whether it's enough, whether they're monitoring the right things in the right places, and there's teething problems in the scales on the axes when you plot the graphs up. But that's fine. But the principle of the data being mapped, being made available, that's at least starting to be recognised. But we need to go a lot further to make sure we are monitoring all the aquifers properly at the right frequency, so we can adapt for all the processes that are going on, whether it's farmers, whether it's drought, floods, all of these things that are going on in a system, so that way on all the data is connected. There are people that I've worked with for a few years now up in Queensland that didn't even know you could get basic production data on CSG and the water extracted. Now, they've asked government departments before and they've never got an answer, right? And yet I've just seen that stuff for years. That's been around. So sometimes, even though some data is available, people don't know it's there. Yep. So I think making sure we link all of these things together so that we can do sort of, I think, what you're getting at, I think is a really, really important step. But we've still got a long way to go.
Yeah.
Yep.
It's a big issue. Can we have the man in the jacket, and then does the man behind you, let him go first, please, and then you. No, he's got a mic. Just wait. We'll be quick. Please. Thank you for waiting.
You talk about time frames of studies and so on.
Mm.
When the rest of Australia was in drought, we had 5 years of plenty. We just had 2 years of drought.
Mm.
If we took the 2-year water measurements over the first 5 years, it would give us a totally false result, I believe. If we took it over the last 2, it would give us an equally false result. Now, one of the other factors that worries me is the extent to which the water can move. I know, and I've had confirmed by other people, that the rainfall that falls on the hills of Gippsland comes out 250 miles south in Bass Strait, about 1,400 metres below the surface in a sandpipe. Not discovered by any science, discovered by pure luck. Is the 2 years long enough?
Okay, that's a terribly important question, particularly in Australia.
I think Philip nailed it before in that sense. You allow for sensitivity. You allow for, we know the sort of rough ranges. If you're looking at rainfall in some parts of Australia, it can range from 200 millimetres in one year to 1,200 millimetres in another year. So, and we might know the average is maybe somewhere 500 or 600. So we can account for some of those things, but we do need to be mindful. Are we in a wet period, a dry period? And make sure we factor that into any impact assessment or risk assessment, etc. So, but also understand, if you look at Camden, the regional groundwater studies have never been done, so we don't even know where that groundwater goes. I'm sure Philip probably has more insight than me, but some of those questions need to be asked up front.
So Phil, the shorter time, how do you get around that time? Can you do something about it? It's too short, we know, but how do you do it? Or is it too short?
I don't know how we deal with the philosophical problem of this time-based thing and the uncertainty. I mean, it doesn't matter how good our data is, it doesn't matter how careful we are, it doesn't matter how independent we are, there's always going to be uncertainty in our predictions, in our impacts. At what point do we kick in the precautionary principle and say we shouldn't go ahead with whatever it is, this road, this hospital, this bridge, this thing, because of uncertainty? At what point do we say for society the uncertainty is not enough for us to stop this project? I can't answer those questions. I mean, there's another philosophical problem on top of this, is I'm a fan of the movie The Castle because I actually believe that encapsulates what's special about Australia. But I don't think the movie The Castle will go down too well in North Korea. It would be irrelevant in North Korea. The concept that an individual's farm and Wagyu cattle is worth something in North Korea would be bizarre to them. And yet for us it's everything.
No, that's right, thank you.
Rowan Beam from Narrabri. Thank you, scientists, for all of your wonderful insights. I think the social sciences are completely missing from our panel, and I hope that next time we can find them. If I'm a scientist, then I'm one of those. But I'm wondering, in the light of the two really core points that I picked up, is that the two key elements missing is time and data. How can a fast-track MOU answer that question, or would it be the answer that there's $25 billion worth of really good reasons that Santos has to make sure that it's as fast as possible?
Right, who wants to have a go at that?
I'll try.
But we take the point about the social science. As a chair, we went for the specific scientific issues and engineering issues around groundwater. The point is, the issue that Philip just raised of how you make those value judgments, that's where you guys can add great richness, and I apologise, that's all we could do in the time, but you're dead right. Yeah.
Yep. It can't. Really simple. Like if you're dealing with a $25 billion project, why fast-track something that has potentially very big ramifications? And this is the problem in Queensland as well. You've got $180 billion being invested in 4 projects alone, and yet basically the EISs still have some basic flaws. They've never measured dissolved methane in groundwater, and that's despite actually some of the groundwater studies for those EISs being some of the best in that region. And so there's still these key gaps. And so where's the studies on the existing domestic scale CSG projects and the predictions of impacts for those? Where's the monitoring from those projects actually? I've looked, I can't find any. All these Santos have got their data online now, but QGC don't, Origin don't, so I think we need to slow down.
Okay, we need to slow down. Now, last question for the thing. Can you stand and see if you've been very patient, please, with a check shirt. So I have a little eye that's not perfectly true.
Will Darcy is my name. I'm from a group called Stop Coal Seam Gas Sydney Water Catchment. Dr. Pell, you and I attended a conference at Picton in which you made the case that if you were to pick a geology that was most suitable for coal seam gas, the Camden Gas Project was it. I guess the point I wanted to ask is that not a time issue too, in essence, that the effects will be felt? From a geology point of view, the effects of the coal seam gas in that area will be felt, but it just may not be felt for 20, 30, 40 or 50 years' time, rather than 5 years' time. And does that make it less important? I mean, is the effects on that just as important to those people who will be a generation or 2 generations from now as they would be as the effect that they may have on us?
Okay, to answer your question, yes, the reason why I consider it an appropriate area is because of the time it takes 30, 40, 50 years before the depressurisation works through the system. What probably didn't come through clearly is that the wells are decommissioned after about 15 years, so that while long before the depressurisation works through the surface, the repressurisation will catch up with it, and you will never know that there had been any depressurisation. And that's what makes this time thing such a big ticket item, because it's like you can go in there and do the robbery and get out before the police notice you've done it. If that's the case, you'll get away with it. If you go in there and do the robbery and you're mucking around trying to get the safe open and the police come in still, you're in trouble. And that's what's likely to be the case in Gloucester and Narrabri. I don't know enough yet. So yes, the time is the issue. That's why I say the time's such a difficult one. And that's what I was trying to say in regard to Camden.
Okay, look, it's time. We have to go, and our chairman of the whole function needs to get the timetable back under control. Can I just say thank you very much to the panel for the way you've answered questions and dealt with the matters, and the patience of the audience, because I know there's so much more you want to ask and we haven't been able to do that for you. But thank you very, very much for the very professional and rational way. This is what civil society is about, talking things through, bringing the best knowledge to bear, being as transparent as possible. And we must keep fighting for that as part of our Australian culture, just as much as the castle's about Australian culture, about fair income, honest appraisal of who we are and what we're doing. And this is part of that process. So thank you for being part of it, and thank you for contributing to it in such a civil and effective means. Thank you.
If you're interested in the Bride of Gloucester well, I've got some copies of the history here for you.
The Gloucester well
All right.
details. There's 50
Thank you,
copies.
John. I'm quite happy to get Hugh's names for trying to keep us on time. We're very conscious, the gentleman in the middle made the reference to social sciences, we're conscious we didn't do it. You'd appreciate the constraint of the day in an afternoon like this. Another quick point, you've got about 15 minutes break. In the early part of the forum this evening, you'll see an excellent video from Tony and Graffia, which we've taken from Cornell University in the US, live, not tonight, but these particular aspects of well integrity will be addressed then, and the opportunity will bring some of these questions that you've just had or not missed, or missed the opportunity to bring up, you could do again in the forum this evening. So thank you. We'll start again in some 15 minutes.